Hello guys, welcome back to it. So we're going to look at differential calculus from first principles. In other words, we are starting off from exactly where we left off in the rise over run formula, and we're trying to come up with the notations, the behind the scenes work that brought about what we eventually call differentiation. Now, just looking at this, what I did was I ended up just breaking it down into a series of graphs because I was failing to be able to explain it all in one graph. So you have to bear with me if I kind of end up making this video a bit lengthy, but I hope it still makes sense. Okay, so starting off with this graph here, you will notice that we essentially going to begin off with the curve, and we want to find the gradient of the curve. My apologies there. This is my y, this is my x. Okay, so say we want to find the gradient of the curve, let's say at a point B. And from what we've learned before, the best way to be able to do this is to draw a tangent to the point B, which just touches but does not cross or cut the curve at B. So it just touches it. And one of the best ways we can be able to do this is to use the diagram, the second diagram that we have here. Okay, so this is our best tangent that we can draw, where you have roughly the same, let me try and indicate those there, the same amount of space in between there. And that's the best tangent that we can be able to draw. This is what we want to get to. But to begin it off, we can start off with this right here. Okay, so we can begin with a rough estimate. Which actually does cross. So this is the roughest, which means it's very inaccurate, and we can be able to see that it's inaccurate. But this is just for starters. Now, with this kind of a scenario, I'm going to put some notation down here. I'm going to call this point A, and I'm going to call this point B, as we have B there. Then remember that the objective is to try and find the gradient at B. But to be able to do that, we cannot find the gradient using the change in y over change in x when we only have one point like we have there. So we have to establish a second point. And to be able to do that, we start off with this rough estimate. And remember that the graph we have, we're going to call it y is equals to f of x. It has to be a function of x. And when we then give or allocate ordinates as follows, then it means that if my ordinate for A, my x ordinate for A is x1, then the y ordinate will be f of x1, because that's what y is. Y is f of x. And similarly, if my x ordinate for B is x2, then it means that my y ordinate is going to be f of x2. So that gives us a system of coordinates, which I'm going to write briefly here. I'm going to summarize here. So why are we writing everything in terms of x? Is because, as we know, our function is in terms of x, or exclusively in terms of x. That's why it's f of x. And we want our function of the gradient as well to be in terms of x. And so we'll express everything in terms of x. And you see how far reaching the statement will be as we proceed. Okay, so these are the coordinates now that we have for both A and B. And to be able to find the gradient for the line AB, okay, we just have to move this a bit further down, I guess. Right. Then we'll have to use our normal gradient line AB is going to be equals to change in y over change in x. But what's the change in y according to this? The change in y is going to be this one. And then the change in x is going to be this one. So how are we going to write that there? It's going to be f of x2 minus f of x1 over x2 minus x1. But because we want everything in terms of x, we can afford to even write this as f of x2 minus f of x1 over change in x. So we can afford to write it like this. And let's continue this in the next video. I hope this has made sense in the interim. And please remember that the objective is to find the gradient at point B on the curve. And because the gradient is forever changing on a curve, it means that we cannot classify the solution for the gradient for a curve like this. We cannot classify it as just one number. It has to be changing numbers. And what's the best way to summarize a series of changing numbers is to use a function. And hence the reason why we need to have this kind of a setup. Okay, let's look at the next video that follows.